Hi guys, today I'm gonna review some keywords for the module of environmental cabin system, and I just got another 100 in this exam. And first thing, in ATA chapter 21, the air conditioning, and ATA 35 oxygen, ATA 36 pneumatic, and we learned the ITO standard, which is 29.92 inch mercury and 1013.2 millimeter bar and 1460.69 psi, and temperature is 15 Celsius and 59 Fahrenheit. And we learned the definition of hypoxia, which is the situation that body is deprived of adequate oxygen supply. And again, we learned the carbon monoxide poisoning, and we learned the detector can change darker color when they detect carbon monoxide. And we also learned that it is necessary to supply the oxygen in the height of 10,000 feet, and the gaseous oxygen is the steel cylinder pressure range is from 1800 to 2400 psi, and the liquid oxygen is normally used by military, and they should be stay in liquid below the temperature -181 Fahrenheit or -118 Celsius. As long as the temperature arise above that temperature, no matter the pressure, is the liquid gonna turns to gas, and the ratio is 862. 1 liter liquid oxygen gonna turn to 862 liters gaseous oxygen. And we also learned there used to be an old bottle which has lower pressure, which is 450 psi, but it's not used anymore. And the new bottle for gaseous oxygen is green steel cylinder, and the pressure range is from 1800 to 2400 psi. Liquid oxygen, commonly referred to LOX, it's obtained by combined cooling and the pressurization process. And there's also kind of oxygen, which is solid oxygen generator, and another name for it is the solid oxygen candle. The oxygen is produced by the combustion of chloride candle, and there are sodium chloride inside the candle. And also we learned that 3 types of seamless steel cylinder, which is 3AA and 3HA. They are steel cylinder, and 3AL is aluminum cylinder. And we learned the pressurization system, and there's normally 3 indicator: cabin pressure, pressure differential, and the cabin rate of climb, which is the same as the cabin vertical speed. And also next we learn the thermal discharge disk with color of green. The disk will blow out when the pressure inside the oxygen system is too high. It's gonna blow out and run the oxygen overboard. And next we learn the barometric control valve. It's kind of auto constant flow oxygen system, and what we need to do just to open the valve and it will adjust the cabin altitude in accordance with the outside atmosphere. And next we learn the pressure demand regulator. It should be used above 40,000 feet, and there will be more pressure from the regulator system than the ambient pressure, so that it can push oxygen into lungs. And we also learned the rebreather type of masks. It's a kind of constant oxygen system too. And there are two types of demand masks, which is the diluter demand mask and the pressure demand type. And it has to be fit tightly to face. And also we learn normal cabin altitude climb and descent rate are 50 feet per minute and descent 300 feet per minute. And the oxygen system is considered empty when the pressure gets down to 50 to 100 psi, not completely empty. Because if it's completely empty, air in the atmosphere gonna move in the cylinder within water or moisture, which gonna be cause corrosion issue, and there's gonna be water inside the cylinder. And next we learned when the landing gear safety switch and solenoid such off the vacuum to the safety valve, closing it on takeoff, and all the packs, which are pneumatic air conditioning kits, feed cold air into a common manifold, and the trim air valve can combine the bleed air and conditioned air from the packs to a desired temperature. Exhaust throat heater have the possibility of the carbon monoxide poisoning from leak, and the nose gear switch operates the ventilation fan when the aircraft is on the ground. That's probably the reason why when we test the combustion heater, when we put the switch on heat position, just the combustion blower works, the ventilation fan doesn't work. It's probably this reason, and we didn't push in the nose gear switch circuit breaker in. And next, the pack valve shuts off the regulator and regulates the flow air into the system, and the anti-ice refrigerant bypass valve keeps temperature exceeding the ACM from getting too cold. The in-temperature control valve also as air passes through the air cycle machine turbine. Actually, it's a kind of expansion turbine. There's a large decrease in pressure and temperature. The water separator is kept from freezing by mixing the air in the water separator with warm air taken from the inlet of the ACM compressor, which is the same function with the anti-ice refrigerant bypass. Take the inlet ACM compressed air to the outside of ACM. And the function of condenser is transfer the heat from refrigerant to ambient air. In that process, the vapor refrigerant gonna turns liquid and give out heat to ambient air, maybe room air or out air. And the evaporator, actually the module works as a cooler, and it absorbs heat and changes the refrigerant from liquid to a gas. And the position of the thermal expansion is determined by the temperature of refrigerant leaving the evaporator. And from one side of the expansion valve is high side, the other side is low side. A steady stream of bubble in the receiver dryer side class indicates a low charge of refrigerant. Also, if there's a troubleshooting in this section, if the no bubble in the set class, but the conditioning system doesn't work, doesn't cool down at all, it means there's a leak in the vapor cycle air conditioning system. And the manifold side is used to evacuate and add refrigerant to the air conditioning. And to check the vapor cycle system compressor oil level, the system should be operated for at least 15 minutes and then completely evacuate and then service it. That's it for this module, environmental cabin system. Thank you very much.